Good day to you from Chem Help ASAP. Let's see how kinetics are relevant to the E2 reaction. On the left at the top of the screen, we have a model of an E2 reaction. The reaction coordinate diagram is in the upper right. What do we know about the E2? The E stands for elimination, so the reaction will form a new pi bond. The 2 stands for second order in the rate determining step. The reaction coordinate diagram on the right indicates that the E2 only has one step. So that one step is second order. Here is the rate equation for the E2 reaction. So we have K times the concentration of our alkyl halide, I'm just going to write halide, times the concentration of our base. The reaction has an overall order of 2. It is first order with regard to the halide and first order with regard to the base. E2 reactions are sometimes slow. How can they be made to go faster? Well, you can always add more of the base. More base will increase the rate of the reaction. One thing you often see in E2 reactions is the use of heat. Heat does not obviously appear in the rate equation, but it's there. It's actually hidden in the different variables that determine K, our rate constant. If you raise the temperature, so we'll put a delta underneath our arrow, you increase the value of K. By increasing the temperature, you make K larger and rate becomes larger. Actually, by adding heat, you give the molecules more kinetic energy. The molecules collide at a faster rate, and the probability of having a fruitful collision for the E2 reaction rises. So the E2 reaction is second order in the rate determining step, and the rate depends on both the concentration of the alkyl halide and base.